So you've just heard all sorts of wonderful things about me. The points that are probably most relevant to our presentation tonight is that I've been a professional artisan blacksmith since 92, really closer to about 85 if you include the time I worked at Black Creek Pioneer Village. I have become very much a specialist in the Viking Age, particularly the material culture of the Scandinavians. And we're looking at a period from about 800 to 1000 AD there. And I've done a lot of work in association with Parks Canada at the only authenticated Viking artifact site in North America, which is at Meadows, Newfoundland. If you know the rock, is that the right way around for you? If you get off at the ferry down here in Port aux Basques and you drive 12 hours until the road stops at the top end of the Northern Peninsula, that's where Meadows is. Because of work I did at Meadows, I originally got involved in a research project with them in 2001 year to try to replicate the iron smelt that was done by the Scandinavians, the first iron that was made in North America. And as it turned out, we didn't do the world's best job, but I got a bug at that point, and I was just sure I was going to make this work. And since then, I've done over 100 individual Bloomery iron smelting firings. So I'm going to have to give you some background technical language here, so we're on an even keel about what I'm going to be describing. And our 20th century world, although plastics are very important, is really the age of steel. The amount of new steel that is made in Canada divided by the number of people living in Canada works out to 328 kilos per person every year. Think about how much steel is in your car. Think about your washing machine. Think about every bridge you drive under. All of these objects are made of steel. Plastics, on the other hand, which are really dominating our discussion right now, is literally only half that volume every year. Where does iron come from? And now we're going to get into your high school chemistry, you all remember, right? Iron is a pure element, and the original composition of the Earth was primarily iron with some nickel mixed into it. And as the Earth started to cool, iron reacts quickly with oxygen. Everybody who's scratched the paint on their car knows this personally. And what you get is iron oxide, which is rust. Obviously, rust you can't do anything with. Almost all the iron on the Earth's surface is in fact oxidized. As soon as the Earth cooled enough that there could be liquid water, that iron oxidized. And all over the Earth's surface, there are thick layers of what they call banded iron, which is the oxide that was deposited literally 1 billion years ago on the Earth's surface. Most modern mines here in Canada are actually digging into these layers of ancient iron oxide. There are a couple of different forms of ore, and later on, you can come by the table, I've got physical samples of all these things here. One source of raw iron oxide are hematite and magnetite. That's Fe3O4. This will be important later. And a good source for this material is Quebec, and I've got some Quebec material here. There's another important iron source that you found over the northern world. You won't find it here in Grey County. There is no iron ore in Grey County at all, unfortunately. Big problem for me. But if you get up into the Shield country, how many of those here have done any camping or backpacking up in Northern Ontario? A few of you? Well, you know when you're walking through the bush, you'll see a little stream, and it's got that oil slick effect on the surface, and you get kind of a powdery red material deposited there. That is primary bog iron ore. It has a bit of a complicated chemistry. And let's see if I actually get into it. Right. So there's a shot from actually northern Newfoundland, and you can see that oil slick effect. And the material you get deposited in a stream. Well, you need a rock underneath that has iron in it. So basalt in Europe, and here in North America, it's granite. And then you need a stagnant peat bog on top of that. When the plants in the bog die, they fall into the water and they make tannic acid. The tannic acid leaches the elemental iron out of the rocks. Now you've got atoms of iron in the water, you can't get at it. What you have to do is take that water and somehow bubble it. If it's a big pond, the waves will do it splashing over, or you get a stream that comes out of the bog and it runs over the rocks and it tumbles, and the oxygen in the air mixes with the iron in the water and makes iron oxide. Now comes the weird thing. There's a bacteria. The bacteria is anaerobic. It grows away from oxygen. So it lives between the vegetation layer on the top of the ground and the sterile subsoil where the gravel is. And it takes the water into its body, the little bits of iron oxide it thinks is a poison, so it puts it in vacuoles, little pockets in its body. They like to live in colonies. When they die, they leave the little grains behind. Imagine like flour. But it collects up, and if you collect up enough of it, you get a blob. That blob is a very, very pure form of iron oxide, and it was used historically all through Europe. This phenomenon occurs over the whole top side of the planet. Where could you get actually metallic iron on the Earth's surface? The answer is kind of no. So there are two possibilities. One is the core of the Earth itself is still a huge molten ball of nickel iron. So if you get a particularly deep volcano, the material that comes up from under the Earth is in fact nickel iron. One example of this is Disco Island between Baffin and Greenland, which is essentially a huge block of iron. And the other way you can find metal, pure metal iron on the Earth's surface is the weird one, because it's extraterrestrial iron. The planet that used to be between Mars and Jupiter that broke up and made asteroids, some of those pieces, when they hit the Earth, are in fact nickel iron. And somebody asked earlier about how you can tell it's meteor iron. It has 7 to 15% nickel content. Human beings couldn't do that until the late 1800s. So as soon as you find a really, really heavy rock, and there's a couple of pieces of meteorite on the table, come on, take a look after, you know you've got something weird. All the objects made of iron that humans possessed before about 1500, before the Christian era, are in fact pieces of nickel iron meteors. The most famous object is the dagger that was in King Tut's tomb, which is in fact a meteor that they've managed to trace to northern Egypt. The oldest worked piece of iron we know about is 3200 BC. So in terms of metals, it's a very, very unusual one. It's a new one in our repertoire of technology. Curiously enough, the only iron that was worked in North America is by the native groups living in the high Arctic, where there's no fire. Because in the wintertime, meteor hits the ice. In the spring, the ice melts, and there's a rock in the middle of the snow. What's that about? And they would take those meteors, which are quite brittle, and they would break them up between two stones and take the little sharp chips that are left over and then inlay them in a piece of bone or antler for spear tips or harpoon tips. So they're not actually making the iron, but they are utilizing it. So how do you actually make this? Our problem is that all we've got on the Earth's surface are either these rusty red colored rocks, again there's some samples on the table, or we've got this clay-like red substance, the bog ore. What we have to do technically is make a fireproof container. The simple thing to do is just take some clay and make a cylinder out of clay. You can use rock, but it's got to be something that will withstand quite high temperatures. And then what you're going to do is you're going to fill that with charcoal. Charcoal burns hot and clean, particularly if you give it some air blast. The more air you give it, the higher the temperature is going to be inside of your furnace. And we're looking at creating temperatures in the range of about 1400 degrees Celsius here. And then what we do is we throw the ore on the top. We're setting fire to it and we're burning things, so the charcoal goes away. So we throw some more charcoal in, some more ore, and some more charcoal, and some more ore. And we do that for, 4 or 5 hours. What happens chemically in the furnace, now we go back to your high school chemistry, is the burning at high temperature creates carbon monoxide gas. Carbon monoxide is not very stable. So what happens is the carbon monoxide wants to be carbon dioxide, and it grabs the oxygen off the iron oxide ore we put in. And the carbon dioxide blows at the top, and the little particles of iron then are left inside the furnace. They're reduced. Now, the little particles of iron are heavy. Think about at home when you've got that molasses brown sugar, and it all sticks together in the bottom of the bowl. That's exactly what happens. It's almost identical in terms of small particles sintering together, sticking together to make a mass. Now, the other thing that happens in the furnace is the ore has got other garbage mixed in with it. And it's so hot in the furnace, we're melting the walls. So the ash from the charcoal, the silica from the dirt and the walls sticks together and makes a real primitive kind of glass. The furnace is so hot that that glass is liquid. Also a glass, it's heavy. It falls to the bottom of the furnace. The bottom of the furnace is cold and it freezes. But the top of that liquid stays fluid because it's still hot. The iron particles are heavier than the glass. So they fall to the bottom through the liquid and they hit the solid bottom of that bowl. And they all stick together. If you do everything just right, hold your nose correctly, and you built your furnace properly, and you've danced around the sacrifice of the right God, at the end, you can pull out a spongy mass of iron called a bloom. This is where the language comes from. The furnace we use is called a Bloomery furnace because of the process we're using. All right? And the bloom that's here on the table is one we made for my 70th birthday, my 65th birthday. We did 65 kilos of all the ores we'd ever worked with, and that's a 17.5 kilo bloom. You can see it's about the size of a soccer ball. It's almost impossible to work with human tools, manpower tools, because of the raw size of it. We don't normally make our blooms that large. So, important to this discussion about metals are some modern types of metals and how they compare to this ancient stuff. You will all be aware of alloy steels. The most common example that everybody has at home is adding a small percentage, about 1-2% nickel, gives you stain-resistant steel, stainless steel, which is what all your cookware is made out of. That's completely modern, however. The main thing that alters the quality of raw iron are adding very, very small amounts of carbon. Those of you who are serious cooks may have carbon steel knives at home. Those are the real serious sharp ones you bring out, but they rust like crazy, particularly if you cut an onion or a green pepper. So you have to clean them off right away. Small amounts of carbon in the mix can radically change the quality of that iron. And we're talking about percentages in the range of part of 1%. At 1% carbon content, you have the material that you would use to make a file out of. At 0.5% carbon, we have a spring steel. And back in the day, for those of us who can remember this, you know, GM pickup truck springs were made of straight 1045, as they used to call it, 0.5% carbon steel. And you just made them big, and they lasted forever. The temperature in your furnace will determine what you get as your final product. Now, if you put too much carbon in, and what we're talking about here is something in the name of 2 to 5% carbon, hardly any, you change the melting point of the metal. Now what you can do is you can liquefy it before it physically reoxidizes. With this material, you can pour it off and put it into molds and make fry pans or stoves. The problem is you can't forge it. You can't heat it up and hammer it. It's brittle. How many of you have broken a fry pan by dropping it and having it hit a rock? That's what the problem is with that. It's really easy to make fry pans, but you can't do anything else but make a liquid shape out of it. They talk about pig iron. That's because during the medieval period, the way they used to utilize this cast iron out of the furnace is they would cut a trough from the furnace in the sand of the floor and have little lumps come off the side, which looks like a bunch of piglets nursing at a sow. And that's where that name comes from. So it's really just cast iron, but it's a shape of cast iron. And this is going to come up again. Cast iron isn't utilized in Europe until really the later part of the 1500s. It's a post-medieval object. So how does that connect to our modern world? In around 1855, I'm going to go backwards in time here. Around 1855, they developed a new kind of furnace, what's called the Bessemer blast furnace. And the Americans and the British argue about who really invented this. There's two different patents. They're both from about 1855, 1856. And essentially what you do is you take that big pool of cast iron and you blow air through it. And what blowing air through it does is it eats up the carbon and reduces the carbon content. So now you can take your cast iron and turn it back into this new material, steel, the same steel that our world is made out of. Steel is a great thing because you can machine it. And surprise, surprise, we're looking at 1850s here, the technology in the early days, it's contemporary for settlement here, right? Where machines start to become more important than things that are hand hammered out. So the metal that was made before 1855 is wrought iron. It may be a bloomery material, and it has to be hammered on to convert it into bars. And again, I would invite you to come up afterwards and take a look at the samples. When you've got a bloom under your furnace, it's got holes in it, and it's got slag mixed in with it. You can't make anything out of it the way it is. What you have to do is you have to take that lump and squeeze it to get all the holes out. And then it gets long and skinny, so what you have to do is fold it up again and hammer on it, it's wrought, okay, to create a solid metal bar. Now, wrought iron has no carbon in it, so it's real easy for the blacksmiths to make things out of. Because it doesn't have any carbon in it, it doesn't rust as fast as our modern metals do, which is why we've got things like the gates up on the Parliament Hill, right, which at this point are pushing 200 years old and not painted. Right? Try that with your car. Okay. It also has a very, very distinctive linear texture. One of the ways you can tell for this is you nick it 3/4 of the way and break it, and you can see you get that tendril effect. That's from the layers of squeezing it together and welding it up. And there's a little piece, again, on the bench you can take a look at easier. This is all the metal that would have been used in pioneer time, settlement era, as when this area was first developed, would have been wrought iron. Wrought iron is not a process. It's not a look. I don't sell wrought iron gates unless somebody really, really has a lot of money. I've got about 450 pounds of this stuff squirreled away. It's all from about 1860. They haven't made wrought iron, real wrought iron metal, anywhere on the Earth's surface after about 1970. So we were talking about I guess I already did this. We were talking about the bloomery, right? It's the name of the thing we take out of the furnace. It's the name of the furnace itself. Okay, so we're taking our ore, we're converting it into wrought iron metal. This can be considered to be an ancient, 1500 BC, up to what you could call the beginning of the industrial age, 1800s. How you might build your furnace is dependent on what ore you use and what ethnic tradition you're working in. A furnace from Japan looks nothing like a furnace from Norway. They're working with different ores. Their whole concept of how to do that, use this technology is different. So there's no one standard way to do this. It varies depending where you are in cultures. So another thing I'm going to throw in here that's going to be kind of important, it has to do with this whole idea about air and temperature. If you put in lots of air, your furnace gets really, really hot. If your furnace is really, really hot, it absorbs too much carbon and you get cast iron. Well, if you're trying to make something you can hammer on, it's failed. And I've got some cast iron we made there by accident on the table. During the later part of the Middle Ages, they figured out they could make cast iron and then put it in another kind of forge, a special kind of forge that was really, really hot, and burn off the surface, the carbon on the surface of that cast iron, and then take those thin plates and weld them together and make bars. The furnace they use for that is called a finery, all right? And it's going to come up when we look more into history. So you've just heard all sorts of wonderful things about me. The points that are probably most relevant to our presentation tonight is that I've been a professional artisan blacksmith since 92, really closer to about 85 if you include the time I worked at Black Creek Pioneer Village. I have become very much a specialist in the Viking Age, particularly the material culture of the Scandinavians. And we're looking at a period from about 800 to 1000 AD there. And I've done a lot of work in association with Parks Canada at the only authenticated Viking artifact site in North America, which is at Meadows, Newfoundland. If you know the rock, is that the right way around for you? If you get off at the ferry down here in Port aux Basques and you drive 12 hours until the road stops at the top end of the Northern Peninsula, that's where Meadows is. Because of work I did at Meadows, I originally got involved in a research project with them in 2001 year to try to replicate the iron smelt that was done by the Scandinavians, the first iron that was made in North America. And as it turned out, we didn't do the world's best job, but I got a bug at that point, and I was just sure I was going to make this work. And since then, I've done over 100 individual Bloomery iron smelting firings. So I'm going to have to give you some background technical language here, so we're on an even keel about what I'm going to be describing. And our 20th century world, although plastics are very important, is really the age of steel. The amount of new steel that is made in Canada divided by the number of people living in Canada works out to 328 kilos per person every year. Think about how much steel is in your car. Think about your washing machine. Think about every bridge you drive under. All of these objects are made of steel. Plastics, on the other hand, which are really dominating our discussion right now, is literally only half that volume every year.